welcome to AD Mathematics, and in this video we are going to solve a lot of examples under sets. Notice in the previous video we said we are done with all that we have to do with sets, but then I noticed that we didn't get time to solve a lot of examples, and I will teach you tricks as well. Now we started sets, so please, if you are new to this channel, I will recommend that you go back and then you watch the previous videos. I've explained the basics and the why we do things. Yeah. So if you have not watched those videos, you have to watch it. Else, I don't think you're going to understand. Okay. So we started said by we said a set. We started with the definition of sets. Now we came to reduction of sets, right? That's the most important thing. Let's start from reduction of sets. Now we said when you are being asked to reduce a set, so let's take the first example, square root of 32. What you have to do is to write down the factors of 32, because we said a set is only in a basic form if it has no perfect number, or if its factors have no perfect number, right? So we said list down the factors of 32. So let's try to do that. 1, 2, 4, 8, 16. Okay. So these are the factors of 32. Then you ask yourself, among these factors, do we have a perfect number? I mean, any number which is perfect? Yes. The answer is yes. And we have 16 or 4, right? 4 is also a perfect number. 16 is a perfect number. So it's all your choice. Yeah, but I will always advise to take the higher number. Why? Because when you take the smaller number, your final answer will not be in a basic form, and you still have to reduce it. Let's take 4 for an example. So we say, so we take 4, right? Then you ask yourself, 4 times which number is going to give me 32? And the answer is 8, right? 4 times 8. So we say 4 8 is equal to 32, right? So we can see square root of 32 is the same as square root of 4 times 8. And then with the rules that we learned earlier, we said when you have square root of a times b, it is the same as square root of a times square root of b. So with this one, it is the same as square root of 4 times square root of 8. Now, what is the square root of 4? Notice we said here we are dealing with the positive square root. In actual sense, square root of 4, we know is 2, right? But it's equal to plus or minus 2. Yeah, because when you square negative 2, you are going to get 4. So, but under this topic, we are dealing with positive square root. So, if I don't mention, please, you have to know that you are dealing with positive square root. So, what is the square root of 4? The answer is 2, right? And now, so we have 2 times. Do we have the square root of 8? Now, we don't know. And also, is this, so we have 2 times root of 8. So let's ask ourselves, which is basically 2 root 8, right? You ask yourself, can this be my final answer? We said a set is in a basic form if any of its factors are not perfect, right? I mean perfect squares, right? So now 8, let's look at the factors of 8. Let me see. Factors of 8 are 1, 2, 4, and 8. So you see that it has a perfect square which is 4, right? So we can still simplify it further. So we say square root of 8 is the same as square root of, so you take that perfect factor, 4 times which number, 4 times which number is going to give you 8? The answer is 2, right? So we can reduce this to square root of 4 times square root of 2, giving us, what is the square root of 4? 2. 2 root 2. So notice we had 2 root 8, and then we are saying root of 8 is equal to 2 root 2. So here, these 2, we shouldn't neglect it. It's more like we are having 2 times root of 8, right? And now root of 8 is equal to this. So we have 2 times 2 root 2. Notice we said when you have A times B root C, we just multiply this by this and leave that, and then we have AB root C per the rule that we learned, right? So we are going to get 2 times 2, which is 4, or root 2. So now we can see square root of 32 is equal to 4 root 2. And this expression is in its basic form because the factors of 2 are 1 and 2. None of the factors are perfect square numbers. Okay, I hope you really get this. Okay, now someone is asking what's the perfect square, or how do we even get a perfect square number? It's very, very simple. Try to list down the counting numbers. So let's list the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So now when you take the first counting number, multiply it by itself. 1 by 1 is 1. Then you take the next number, which is 2. 2 times 2 is 4. And then you take the next number, which is 3. 3 times 3 is 9. You take 4. 4 times 4 is 16. You take 5. 5 times 5 is 25. 6 times 6, 36. 7 times 7, 49. It goes on and on and on. Notice we see 1 is a perfect, 1 is perfect, 4 is also perfect, 9 is also perfect. But 3 is not perfect. You have to notice the difference, right? So now basically when you have to reduce it, you have to go through the you have to go through the process of writing the factors and then checking to see if the factors are not perfect, right? But we are students, we are sorry, when the question is given to us, we are bounded by time, right? So now, can there be a shortcut for we getting the final answer? Notice this channel is not meant to just pass. The aim of this is to understand. That's why I taught you the basics. So you have to understand whatever that we are doing. Understand. But then there is a trick to help you so that you are going to excel in your exam. Because in the exam you are bounded by time. Let's jump into the trick. Now, notice something. Sorry, hold on. Okay, so before we continue, I think when we were writing the factors of 32, 16 was also there, and I advise that we take the factor which is higher, right? So let's take that one. So square root of 32 is equal to square root of 16 times, which number is going to give us 32? The answer is 2, because 16 times 2 is 32, right? So now we see this is the same as square root of 16 per the root times square root of 2, because we said square root of A times B is equal to square root of A times square root of B, right? So now square root of 16 is 4. And what is, so we have 4 times, what is square root of 2? It's in a basic form. And we have 4 root 2. Notice it is the same thing that we had when we chose the 4. So either ways, you are going to get the same answer. Now let's come back to the trick. How are we going to be fast? Because this method rely on your ability to be able to know the factors. But you see, when you have example like example 6, example 5, example 4, these are huge numbers that you have to go a long way before you write down the factors. What if I tell you there's a simple way to do that? Now, here's how the trick works. We saw when we were dealing with multiplication of cells that, let's say I have a number, say A. If I want to write this one with a square root sign, all that I have to do is just say A squared, square root of A squared, because I know that square root of A squared is the same as A, right? So when I have an A is a number. So when I have a number and I want to put it in a square root without changing the number, all I can do is to square the number and then find the square root. And it's quite logical. What is the meaning of square root? Square root means two numbers that you multiply. So when you say square root of 9, it means what two numbers do you multiply to get 9? And the answer is 3, right? So if I have 3 times 3, and then I ask you to find the square root, it's basically the 3, because whatever 3 times 3 is giving you, when you find the square root, 3 by itself, not two numbers. What number did you multiply by itself to give you the 9? And answer is 3, right? So now, when I have a number, say 10, and I want to write it with the square root, all I have to do is to write it this way. Square root of 10 times 10. Better still, square root of 100. And we know square root of 100 is 10. You get the logic now. Let's take another example. Let's say I have 7. I want to write this one with the square root. Or per the properties, we said a squared is equal to a, right? So I can say 7 square root of 7 squared is the same as 7. Notice we are dealing with positive square root. Okay, so now as a student, what do you have to do? Okay, so now let's move on. What I was saying was that the trick to it is that you just take your calculator and then you punch. I'm using a Casio calculator. So any calculator that you have, so you punch square root of 32 on that. Now the calculator is going to give you 4 root 2 as your answer. But notice that examiners, they don't just mark your final answer, they mark your method. And when a teacher or you are being asked in an exam to find square root of 32 and then you just write 4 root 2, you will be caught. You will be caught that this student has used a calculator to solve. So in order to skip that, we use that this principle that anytime I have a number, say a, and I want to put it in a square root, I only have to square that number inside the square root, right? Okay, so let's do that. So now the calculator has given us 4 root 2. How do we sorry, how do we make it look as if we did it on our own? Yes. So what we can do is that we have to bring the 4 inside the square root. And how do we do that? For you to bring a number inside this, we have to square that number, right? So you can simply see then I have square root of 2. We are bringing the 4, right? Times 4. But for you to bring a number into the square root, you have to square that number. So you can say 4 squared, right? Better still, if you want it to look real, you can do it this way. So you can expand this 4 squared, right? So what is 4 squared? Is 16. So instead of writing this one, you can say square root of 2 times 16. And then you come and write the answer the calculator gave you, which is 4 root 2. Because every examiner knows that anytime you have this one, or you can go a step further by saying square root of 2 times square root of 16, giving you 4 times root of 2, which is 4 root 2 that the calculator gave you. Let's solve the next example. I think you will get it better. Say the 2 is example square root of 8. I don't know the factors of 8. So what I do is that I'll point the square root of 8 on my calculator. And when I point it, I'm going to get 2 root 2. But then when I write this answer, if it is an OBJ or MCQ, you are good to go. You can point it on a calculator and then you get your final answer. But then here you have been asked to show working. So you don't just write the 2 root 2. Instead, you write solution. Right? Now, what is the calculator giving us? 2 root 2, right? So you have to send these 2 into the square root. How do we do that? Oh, it's simple. Remember, 2 root 2 is the same as, okay, forget it. Let's send the 2 into the square root. So we can just send into the, here is 2. We have root of 2 already, so we write it. Then we multiply by these 2 outside, right? But we are saying for you to bring a number from here into the square root, you have to square that number so that you can say you get back to your final answer. Remember, we've learned this principle. A is equal to square root of a squared. What is 2 squared? So you can point 2 squared on a calculator, you get 4. So you can say the same as 2 times 4, right? So you say square root of 8 is equal to square root of 2 times 4. And this expression is the same as square root of 2 times square root of 4. Another properties of multiplying set, we learned this one. What is square root of 4? We have to multiply. So this is 2, and this is what? Root of 2. And now you can now go ahead to write the answer the calculator gave you, 2 root 2. This one, there is no way you are going to get it wrong. Let's solve example 3 with that. Example 3. Yes, so example 3, we have square root of 128. So you just punch it on your calculator, square root of 128. The calculator is giving me 8 root 2. But you don't just go ahead to write this, rather you take it step by step, right? So solution. I know this is what the calculator gave me. So what I can do is that there is root of 2, so I can write that one times this 8 which is outside. But I know that for me to bring a number outside the square root to inside the square root, or yeah, I have to square that number. So I square this one, right? So which is the same as 2 times 64, square root of 2 times 64. So you can choose not to write this one, or rather you write this one rather. And then you know that this expression is the same as square root of 2 times square root of 64. And square root of 2 is a set. But then square root of 64 is giving you at 8. So you just go ahead and write 8 root 2. Really by enjoying it. Okay, let's take the fourth example. Square root of 400. So you punch it on the calculator. Square root of 400. Now the calculator is giving me 20. What it means is that 400 is a perfect square. Yeah, so with this one, so 20, right? But you don't just go ahead and write the 20. What do? Solution. So it says square root of 400 is equal to, the calculator gave you 20, right? So you have to move the 20 to the square root. You have to move it inside the square root. So what do? You say square root. So you bring the 20, but you don't just bring the 20. You have to square it, right? And squaring a number means a squared is the same as a times a. So the same as square root of 20 times 20. And now you can use the property of set, that square root of a times a is equal to a. And we say square root of 20 times 20 is equal to 20. And then you write your final answer. Let's look at example 5. Square root of 700. Remember, if you want to understand how I've already taught the steps, the step is to write down the factors of the number, check if it has a perfect square, and if it doesn't have, then you can go ahead and say it is in a basic form. Therefore, you cannot do anything to it. You leave it like so. So let's point square root of 700 on our calculator. The calculator is giving us 10 root 7, right? But if you write this, you are not going to get the full mark. In fact, you are going to be marked down. So what you can do is move 10 inside the square root. How do we do that? Simple. Just move it. So 7 times the 10, right? But for you to move a number here, from here to here, you have to square that number. So we square the 10, giving us square root of 7 times 100. And now you can go ahead and square root times 100 is the same as square root of 7 times square root of 100, giving us 10 root 7. I think some examiners, when you write square root of 7 times 100, and then you go ahead to write your final answer, they will give it to you. But to be more safe, use this property and then you are good to go. Okay, so the last example, example 6, we are being asked to find square root of 900, square root of 900, which is the same as, so you punch it on your calculator, square root of 900, and I'm having 30, meaning it's a perfect square, right? But you then just go ahead and write the 30. I think if it is perfect, you are good to go. But better still, if you still want to do some one or two things to show that you actually did, you can say it's equal to square root. So you bring this 30 inside the square root, 30 times 30. And then you move on to say the answer is equal to 30, because by the properties of set, a times a, square root of a times a is equal to a. Okay, so let's move on to the next set, which is addition and subtraction. Now notice that we said for you to add or subtract set, it must be in a basic form. So now by the grace of God, we understand how to reduce set to a basic form using our calculator. So we shouldn't even struggle to do it. So the first example, I'm going to solve it with the normal approach. Yeah, we said for you to add set, first of all, check if it is in a basic form. If it is not, try to make sure it is in a basic form before you operates, yes. And so how do we add set? The first one is 5 root 3 plus 4 root 3, right? And we said it's also a number. Square root of 3, when you point it on a calculator, you are going to get 1.7320. It goes on, it never terminates, right? So we always leave it in this form. But then remember your basic algebraic expressions. For example, when you have AB plus BC, where we said, oh, we can factorize B out. So you factorize B out, and then you say AB over B is giving you what? AB over B is giving you A. So here it becomes A. Or you say B goes into AB how many times? Which is A times. Plus B is here. So you factorize out, leaving C. So we have B multiplying A plus C, right? It's the same thing we said. It's the same thing we said. Nothing changed. It's the same thing. So here we can say, if you are using the normal approach, we say, oh, let's factorize root of 3 out. So we do so, factorize root of 3 out, and then we say root of 3 goes into this one, or in other words, this one divided by root of 3. So we have 5 root 3 over root of 3. What do we have? We have 5, right? Then we come here, 4 root 3 over root of 3. We have what? Positive 4. So we have root of 3 multiplying 5 plus 4, which is 9. And I told you A times root of B is the same as root of B times A, giving us A root B. So 9 times root of 3 is going to give us 9 root 3, right? So with this one, we use the factorization approach, but then that one is also quite tedious. Let me show you a simple trick. So let's use that example. 3 plus 4 root 3. I think I've already taught you this in the previous video. We said, you see, it is in a form A root B. And here we are adding it to C root B, right? I told you, let's factorize root of B out. When you factorize, you are going to get A plus C, right? So the trick is not actually a trick, it's a derivation of our understanding or how we understand it. So it's always the square root or the third part and then the sum of the numbers multiplying the various cells, right? So here we have 5 root 3 plus root of 3. You don't need to factorize. Or you can say, oh, let me maintain my root of 3 and then let me add these numbers outside the cell, 5 and 4, giving me 9. And so I have 9 root 3. Okay, let's use that to solve more examples. We are solving. Okay, so let's look at example 2. We have root of 3 minus 2 root 3, right? Notice the first two examples, the set is in its basic form. So we don't necessarily, we already know it is in its basic form. That's why we don't reduce it, because when the set is in its basic form, you can't reduce it, right? So now the rule is saying add the numbers outside the square root and then multiply it by the number inside the square root. So we know that definitely, since here is root of 3 and here is also root of 3, we are going to get root of 3 multiplying a certain numbers, right? Which is then the number here and then the number here. But then ask yourself, what is the number here? Nothing is written, but I always tell you that square root of 3 is the same as 1 times square root of 3. In fact, not only square root of 3, any number that you have, when you have square root of A, is the same as 1 root A. So here there is 1 here. Let me use this pen. There is 1 here, but we don't write because 1 times any number is that's why we choose. So here we can say this one, and then this is negative 2 minus 2, right? Minus 2. So what do we get? We get minus 1 times root of 3, giving us negative root 3. Or someone will say negative 1 root 3. But I always tell you, when there is 1, you don't necessarily write it. Let's see. Okay. Now let's move on to the third example. We have 1 over 2 with 7. I think this is the first time we are getting a function. plus 7 root 63. Ask yourself, is this root of 7 in its basic form? Yes, because the number itself is prime. And we, from the beginning, I told you the square root of all prime numbers are set. So this is a set. What about 63? Okay, let's punch it on our calculator. If you punch it on your calculator and then you get decimal, the, or the calculator doesn't give you a form A root B, but let's say you gave it C, square root of C, and it still came square root of C, it means it is in its basic form. Okay, so use the calculus calculator. If your calculator is misbehaving, you can click on shift plus 9 and then shift plus 9, you choose 3 and then equal to, you press equal to, it will reset your calculator and then you jump in, right? So now we know how to reduce this one. Let's down the factors, but we've learned a shortcut. Let me punch it on my calculator. And I punch it on my calculator. And I punch square root of 63 on my calculator. I had 3 root 7, right? So all I can do is to move this 3 inside the square root. So when I do that, 3 times 3 is 9, right? So I will get square root of 7 times 9. So that, so learn the property well. When I have square root of A times C is the same as square root of A times square root of C. So in subsequent videos, I'll not necessarily write this one for you. So you have to keep it well. So here, it's more like when I have square root of A times C, I can say, oh, I can find the square root of C and then bring it out, provided it's a perfect square, right? Yeah, so the same opinion. So here, you see, in the previous solution, I was writing the 7 squared for you. I mean the 3 squared for you, but now you see I've written 9. So I expect you to understand. Yeah, so 7 times 9, right? So we can use that same idea. So let's come back to our question. This is the question. Now, we know that square root of 63 is the same as square root of 7 times 9. So we write it again. 1 over 2 root 7 plus 7 multiplying square root of 7 times 9, right? And I know that square root of 7 times 9, what did the calculator give? 3 root 7. And we are just showing working. That's why we didn't just write the answer the calculator gave. You are not necessarily going to get a question on reduction of cells, but then the question you have on cell, in most cases, especially in your WASI exam, most cases you have to reduce it. So don't worry if you don't see reduction of cells in any past question, but I tell you, most of the things that you are going to do, remember, for you to add or subtract cell, you have to reduce it to its basic form. So the basic form is very, very crucial. So keep it. So here, calculator gave us 3 root 7. So let's write it again. I want to go systematic so you understand. Plus 7 multiplying. Calculator gave us 3 root 7. So because square root of 9 is 3, right? So 3 times root of 7 is 3 root 7. Now we have A times B root C. What is the rule saying? For multiplication of cells, the rule is saying right. So here, multiplication similar is, so with multiplication is the same thing. Multiply the one on the outside and then multiply your set. This time around, you are not writing one of the set. So for example, I have A root B multiplying C root D. The trick is that what are the terms outside? These are the terms outside, multiply them. What are the terms inside? These are the terms inside, multiply them. So we have A times C square root of B times D. Do you get it? But here, someone might ask, but here there is no square root. Just as when you have square root of A, it is the same as 1 root A. Remember, the square root of 1 is equal to 1. Therefore, when you have A, you can write A as A square root of 1, right? So here, instead of saying you have A times B root C, we can say we have A root 1 times B root C, right? Now, what is the rule saying? Multiply those on the outside and then multiply those on the inside. So A times B is what? AB. And then terms on the inside is 1 times C. And 1 times any number is that number itself. So we have AB root C. So now, I just want to use that idea to solve this one. That's why I came back. So here, 7 times 3 root 7. You know that there is root of 1 here that we don't write because root of 1 is 1 and 1 times 7 is 7. That's why. So we just multiply them. 7 times 3 is what? 21. And then multiplying root of 1 times root of 7, giving us root of 7. So let's simplify. We have 1 over 2 root 7 from here. And then plus 7 times 3 is 21. And then we bring our root 7 because it is, let me say 7 times 1, right? Which is 7. So now we have root of 7 here, root of 7 here. And I have told you if you want to simplify sets, and if you want to add set, right, and you see that their radicals are equal, what you do is just focus on the terms outside, add them. So here our task is just to add 1 over 2 plus 21 and then choose one of the terms inside, which is root of 7. For addition, we choose one, but for multiplication, we multiply outside and inside also. For addition, if they are of the same, if the number inside the square root are the same, you just, I've showed you, just factorize one out. The idea is factorization. Yes, but with multiplication, we don't factorize. We multiply each term. That's why. So what is 1 over 2 plus 21? Well, I want to write the final answer, but for those of us who don't know how to add fractions, let's use this opportunity to recap. So the first thing is to find your LCM. What's your LCM? Is 2. 2 goes into 2. How many times? 1. 1 times 1 is 1 plus 1 goes into 2. How many times? 2. 2 times 21 is 42. So we have 42 plus 1 is 43. 43 over 2. Right? So here we have 43 over 2 with 7. But for our level SHS, we are not mark, we are not giving mark for this step. So, or for this method. So basically, you can just punch on your calculator 1 over 2 plus 21, and then you get 43 over 2. So you can just, you don't have to go through this, but you have to understand. Remember, the aim of ED mathematics is to help you understand the concept and then excel in life, not only in examination. Okay, we have a long way to go. Let's solve the next example. Yes, so let's take our fourth example. We have 3 root 8 plus 3 root 200 plus 2 over 3 into 162. Notice we cannot add this unless we reduce it, right? So let's see if 8 is already reduced. Let's punch it on the calculator. When I punch square root of 8 on my calculator, I have 2 root 2. I have 2 root 2, but I know, sorry, I don't have to write this. I have to send this 2 inside. So I square, what is the square? The square of 4. Sorry. So we have square root of, the 2 is already here. So multiplying the 4. Such that when I find the square root of 4, it is going to give me 2 and it will come back to this expression. So by now you understand. Okay, so I have 2 root 2, 4. This one. So here I can, okay, let me take it systematically. So 3 times square root of 8 is the same as square root of 2 times 4. Okay, plus, now 3 is here, right? 3 times, what is square root of 200? When I punch it on my calculator, I'm getting 10 root 2. 10 root 2. Meaning, the systematic way to square the 10 giving you 100. I have square root of 2 times 100. This 2 is coming from here. And then this 100 is coming from this 10 because it's outside the square root. And if you want to send it inside, you have to square. So 2 times 100 plus, we maintain our 2 over 3. And then find the square root of 162. Let's point it on our calculator. I have square root of 162 as 9 root 2. But I cannot just write the 9 root 2. I have to send the 9 inside. I square the 9. What is 9 square or 9 times 9 is 81. So I have root of 2 times 81. So say 2 times 81, right? So now let's see. We have 3 times. Can we find the square root of 2? No. Can we find the square root of 4? Yes, which is 2. So this one will move from the square root and then it will come outside. And then the inside remains 2. We have 3 times 2 root 2 plus 3 times. What is square root of 2? We cannot find. What is the square root of 100 is 10. So 10 will come out. 10 root 2. The same thing that the calculator gave us for the square root of 200. 10 root 2. But someone is asking, but the calculator gave us 10 root 2. Why didn't you write it straight? Now, I've already told you we mark steps or method. If your method is wrong, there is no way you are going to get answer. So we see M0, A0. Meaning wrong method, you have to get wrong answer. Even if you use wrong method and you get right answer, you are wrong because your method is wrong. So we do this to show working that you actually lay down the factors to do it. Plus, so we come here, 2 over 3 multiplying. What's the square root of 81? It's 9. Have 9 root 2, right? So now I think we can simplify it further. What is 3 times 2 root 2? I've already told you a times b root c is the same as ab root c. Letter 2 you can say is the same as a root 1 times b root c. So I've already told you for you to multiply cells, this should multiply this and then this should multiply this. Unlike addition where this one is the same as this and then we factorize it out or we choose one then we add this one. With multiplication, take it multiply each term. For example, you have 2 root 3 times 7 root 17. Multiply these 2 by 7, 2 times 7, and then square root of multiply the inside also, 3 times 17. So you simplify, I think 14, and then 3 times 17 is 51, if I'm right. Okay, so let's move on. The same thing. So here 3 times 2 is 6, 6 root 2 plus 3 times 10 is 30, 30 root 2 plus what is 2 over 3 times 9? You can say 3 goes into self 1, goes into 9, 3. 3 times 2 is 6. So we have 6 root 2. Yes. Now this is root of 2, root of 2, root of 2. So we can factorize it out. So we factorize root of 2 out. That's the normal approach. But I've already told you just write one, then you add the terms outside. That's addition. You write 1, you add the terms outside. So we have, what is this? So we have 6 plus 30 plus, here's another 6 plus 6. Okay. So we have root of 2 multiplying. What is this plus 30? 36 plus 6, 42. Giving us 42 root 2. So always when you get the answer, you have to punch the whole of this into your calculator and see if you are going to get this. If you get it, it means you are right. If you get it, it means you are right. Okay. Now let's move on to the next example. I'm moving on to the next. I really hope you're enjoying this lesson. We have square root of 147 minus square root of 75 plus square root of 27. Right? Now I punch square, let me chip in this. You see, before we come to this question, let me chip in. This one, let's assume I'm not saying that's it, we are assuming we had 6 root 2 plus 30 root 2 plus 6 root 3. Here we could have we would have factorized this 2 out, right? And then we get 6 plus 30 and then 6 root 3. Remember, this is not the same as this. So when you factorize, you can't just say I have chosen one. No, that's why I want you to understand the concept and then blend in with the trick. So you don't just say because time you are adding, you have to write one of them. So I'm writing root of 2 and then I'll add the terms outside. No, because The reason behind the trick is that they all have the same radicand. But here, this is 3, this is 2. They are not equal. So you leave this one as it is, like we've left it here. And then you deal with these two. Okay, let's move on to this. Square root of 147. Let me point it on my calculator. I have, calculator gave me 7 root 3, but I know that for me to make it presentable, I have to square the 7, 49. So I can say it's the same as 49 times 3. Before, okay, I can now write 7 root 3. I hope you understand. I just want to make sure you understand. That's why. When I find square root of 75, I have 5 root 3. So I have 5. So you know that 5 root 3. I cannot write the 5 root 3, right? I have to write it all in square root. So I'll write 25 times 3. Okay, plus. And then square root of 27. I have 3 root 3. But you know I cannot write 3 root 3. I have to write it. I have to send this one here. So by squaring it, which is 9. 9 times 3. Okay, so here now when I find the square root of 147, remember I told the calculator gave me 7 root 3. So here I can now simplify to get 7 root 3. 7 root 3 by saying square root of this one is the same as this one. Sorry. Oh, I feel like some of you are still not getting it. That's why, so please, if I'm repeating things, don't worry. For the sake of our brothers who doesn't understand. So let's see. So this one is the same as square root of 49 times square root of 3 minus this is the same as square root of 25 times square root of 3 plus this is the same as square root of 3 times square root of 9, right? Square root of 49 is 7. So we have 7 times root of 3, which is 7 root 3 minus square root of 25 is 5, giving us 5 times root of 3, which is 5 root 3, plus square root of 9 is 3, giving us 3 root 3. Okay, so now this is root of 3, this is root of 3, this is root of 3. They are adding. Remember, addition and subtraction, they go hand in hand. And we told you for you to add or subtract, just any they will be same, but they can just write one root of 3, right? And then you add the terms. Here is 7, here is negative 5, here is positive 3. So what is 7 minus 5 is 2, plus 3 is 5. So I have root of 3 times 5, giving us 5 root 3. Okay, so I will give you this one. Go and solve example 6 on your own, and let's solve example 7. This is quite tricky. Let's solve. Yes, so like I said, go and solve example 6 on your own. Let's solve example 7. Example 7, we have equation square root of 32 plus square root of 128 minus square root of 18 plus square root of 50 being equal to k root 2, right? So now it's simple. Let's reduce it. So yes, this is also a radical equation. Yeah. Before you can solve it, always the key is what? Reduce the set to its basic form. So let's reduce 32 to its basic form. Calculator gave me 4 root 2. Calculator gave me 4 root 2. But I know I cannot write this one. I have to write the whole thing inside the square root. So I will square the 4, giving me 60. And I'll multiply by the root of 2. Okay. And then plus square root of 128. The calculator gave me 8 root 2. But I know I cannot write it straight. Otherwise, they will say I use calculator. So I will square this one, 64. 8 squared is 64. Or 8 times 8 is 64. So we say square root of 2 because of these two. 64. Okay, minus square root of 18. The calculator gave me 3 root 2. But I know I cannot write it. I have to write the whole thing inside the square root. So I'll square the 3. 3 times 3 is 9, right? So 9 times the 2 coming from these two. And then square root of 50. Calculator gave me 5 root 2. And I cannot write it this form. I have to square the 5, giving me 25. 25 times 2 is equal to k root 2, right? So now let's simplify this one. Square root of 16 is what? 4. So we get 4 root 2 for this one. Plus square root of 64 is 6. 8. So we get 8 root 2 for this one. That's the answer the calculator gave. Remember, you see, you've gotten the same thing. Yeah. You are just, if it is OBJ, you don't need to write this. You can just punch this whole thing from here to here on your calculator, and then you will get the answer that we will get when you simplify. Okay, 1 square root of 9 is 3. So 3 root 2 plus 1 square root of 25 is 5. 5 root 2. Then it's equal to k root 2, right? So let's simplify it. Root of 2 here, root of 2 here, root of 2 here. So we can write 1. And then we add. So this is 4. This is 8, positive. This is minus 3, negative 3. This is positive 5 plus 5 being equal to k root 2, right? So now let's simplify. Square root of 2 multiplying. What is 4 plus 8? 12 minus 3, I think it's 9, plus 5 is equal to 14. So here you have 14 is equal to k root 2. 14 times root of 2 is 14 root 2 is equal to k root 2. Now, this is quite logical. If the left hand side and the right hand side are equal, and if this is equal to this, definitely this is equal to this. This is also one condition for cells that are equal. So it's all better still. Someone will say, let's divide both sides by root of 2. We have 14 root 2 over root of 2 is equal to k root 2 over root of 2. Root 2 cancel root 2, root 2 cancel root 2. We have 14 is equal to k. Therefore, k is equal to 14. I believe you understand. Yes. So the key thing is that reduce the set to its basic form. Now, when you get here, you use simple logic. If this is equal to this and this is equal to this, then this is equal to this. Or you can simplify using your normal mathematics skills. You can divide through by root of 2 and then you get. Okay. So I want to solve example 8 with you. And then you try example 5, example 9. Example 9, you have to get 54. That's the answer. So let's see. Square root of 24 minus square root of 96 minus square root of 600 is equal to y 6. So let's punch 24 on a calculator. We get 2 root 6. 2 root 6. But I know I cannot write 2 root 6 just like so. I have to write it. Square the 2. So I have 4 times 6 square root minus. And I have square root of 96, which is 4 root 6. I can say 16 times 6 minus, and then square root of 600. I have 10 root 6. 10 root 6. So I'll just say, then let me square the 10, 100, right? 100 times 6 is equal to y 6. Okay. So here I will say I'll have 2 root 6 minus what is this one? 4 root 6 minus 10 root 6. This is 100. Square root of 100 is equal to y root 6. We can simplify it. We factorize root of 6 out. We have 2 minus 4 minus 10, right? Giving us 2 minus 4 is negative 2. Negative 2 minus 10 is negative 12. So I have minus 12 root 6 is equal to y root 6. What do you think is y? Or y is equal to negative 12. But the answer we were supposed to get was negative 4. I don't know whether we made a mistake somewhere, but the idea is for you to understand. So go and try the last example on your own. You have to get 54. Let me see where we had it wrong. Square root of 24 is 2 root 6. We have it here. Oh, this is plus. Remember, look here. This is plus. So it's plus, it's plus, it's plus, it's plus. 2 plus 4 is 6. 6 minus 10 is negative 4. Sorry. I have negative 4 root 6. So y is equal to negative 4. Yes. Can divide through by root of 6. This will cancel this. Y is equal to negative 4, which is here. Okay. So solve the example 9 on your own. it will be 5. Okay. So now we are going to do with multiplication of sets, right? Yes, multiplication of sets. Yeah, we learn simple tricks and then we move on. Yeah, so let's take the first example. Example 1 is square root of 3 minus 1 multiplying 2 minus root of 3. In this one, the best approach for you to know use is the approach that we've been using. Take this one. Let me change the pen. Take the first multiply it by the whole of this. You take the next step, you multiply by the whole of this also. So let's do that. We take root of 3. We multiply by the whole of this, which is 2 minus root of 3. And then this is minus 1. We write it. And then we multiply by the whole of the same thing. 2 minus root of 3. Here we are expanding with the normal expression, just like when we were doing by expansion. You see, bring A out, multiply by C plus D. And then bring B out, multiply by what? C plus D. Right? Okay. So that's it. We have AC plus blah 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 blah. Do you understand? So here, root of 3 times 2. The idea we have from multiplication of set. By now you should know 2 root 3. If you think you are confused, go back and watch the previous videos. You understand. And I hope I have even explained it when we were solving the other examples. So we take this one, multiply by this. Now, always I have been saying root of A times root of A is equal to A. So here, we are going to get 3. This is minus. So positive times negative is negative. So minus 3. Right. Then we come here. Minus 1 times minus 2. And minus 1 times minus root of 3 will be positive root of 3. I hope you understand this. We have minus 1 root 1 multiplying minus 1 root 3. The rule is that for multiplication, multiply the outside and then multiply the inside. What is the outside? Negative 1 times negative 1. And then giving you positive 1. What is the inside? 1 times 3, giving you 3. That's why we have 1 root 3. Okay, so let's see. Let's group like terms. This is root of 3. Here is also root of 3. So we can group like terms. 2 root 3 plus root of 3. And then minus 3 minus 2 is going to give us minus 5. Minus 5. Right? So here, addition of sets. 2 root 3 plus root of 3. It's more like we have 2x plus x. But you get 3x, right? So it's the same thing. And using the addition of sets, here you are going to get 2 plus 1. When you factorize root of 3, then minus 5. What is 2 plus 1? 3. So we have 3 root 3 minus 5. Okay, let's do. So it's the same thing. I don't want to waste time on this one. But there's simple trick you have to know. But I will show you. I will show you. So let's solve one example again. We have 2 plus root of 3 multiplying root of 3 plus 1. The same idea. We take 2, we multiply by root of 3 plus 1. We take the root of 3, we multiply by root of 3 plus 1. So you take this one, multiply by the whole of this. You take this one, multiply by the whole of that. Okay, so what is 2 times root of 3? We have 2 root 3. What is 2 times 1? We have 2. As what is root of times root of A? We get 3. I've already told you root of A times root of A is equal to A. Okay. Plus, what is root of 3 times 1? It's the same way. Do we have like terms? Yes. So you see, is it not the one we saw? Oh no, this is different. So we have 2 root 3 plus root of 3 plus 2 plus 3. 2 root 3 plus root of 3 is going to give us 3 root 3. And then 2 plus 3 is 5. We have 5 root 3. Okay, that's your final answer. Now, something interesting. I think we can also get this one. Example 4 is also interesting. It's here. Square root of 18 times square root of 75. Now, We know that when you have square root of A multiplying square root of B, just go ahead and multiply the inside, right? Because the outside is 1. So 1, 1, 1. 1 times 1 is 1. We are going to just multiply the inside and get AB. Right? So we are going to do the same thing. What is 18 times 75? I think it's 1350. So I'm going to get is equal to square root of 18 times 75 is equal to square root of 1350, right? But this is not in the basic form, so you cannot leave it like this. You have to reduce it. See, if you have to lay down the factors, you see how you're going to suffer. So you point it on the calculator, square root of 1350. The calculator is going to give you, when you point this on the calculator, will give you 15 with 6. But you cannot write this, right, as your final answer. But because you have to show method. So you square this one, 15 squared. You point it on the calculator. 15 times 15, if my memory is right, you're going to get 225. And then multiply by this 6. Right? And it is now that you can write the calculated answer. Okay, so that was just by the way. Now, let's look at this. The last example here is very, very crucial. Let's say you have A root B, and now you are multiplying, A root B, let's say minus C root D, right? And you are being asked to square it. Now, let's do this expansion and then let's memorize the final value. It will help us a lot. So what is, this one is a number squared means a number multiplied by itself. So here I can say I have A root B minus C root D multiplying A root B minus C root D. In the previous video, we did this, but I don't know whether you recall. So let's expand it from scratch. So we take this one, the first one, multiply by the whole of this. We take the next one, multiply by the whole of the same thing. Expansion. So A root B multiplying A root B, and then minus C root D, and then minus C root D multiplying A root B minus C root D. Quickly, this times this is going to give us multiplication. Multiply the outside and multiply the inside. When I multiply the outside, I get A times A, which is A squared. A squared multiplying square root of B times square root of B is B. So the square root has been eliminated. Minus this one times this. Outside, A times C is AC. Multiplying B times D is what? BD. Okay. Minus C root D times D. Outside, inside, I have AC and then root BD. And then minus times negative is positive, right? This times this. Outside, C times C is what? C squared. And then multiplying D, right? So it's more like we are having A squared B minus, now minus AC root BD minus AC root BD. I think subtraction of cells, right? This is equal to this, so you can take it out. Minus root BD, and then you multiply by AC plus AC factorization, or better to use the idea of addition of cell plus C squared D, right? So what are we getting? We are getting A squared B, this one, and then permit me to write this one next, plus C squared D minus 2AC root BD. Okay, well, the point I wanted to, yes, wow, yes, the point I wanted to prove, I think it will be, I wanted us to memorize this so that we use this to find out. That's quite, it's not that easy for us to do. Okay, yeah, don't worry. I just wanted us to memorize the final expression so that whenever a question is being given to us, we substitute the values. Substitute. I hope if you understand that one, I think I want us to chill. I want us to understand to go a long way to help us. Okay, so when we can solve example 6, let's move on. We are using, I don't want us to spend so much. Okay, so now the concept of rationalization. Oh, my machine. Sorry. Yes. Now, in the previous video, I think I made a certain mistake. I had an expression like, I think, square root of a minus b. When we were doing, I've forgotten, but then you can learn from here. Let me correct that one. We said rationalization means transforming the set so that the final product is what is rational or whole. So a cell shouldn't necessarily have to be in the form a minus root of b before you can rationalize it. We know that when it is in this form, we multiply by its conjugate, right? But then what if it is in a form like 1 over root of a? How do we get to the root of a? I think when I was making the conjugate, I talked about it, but what came over me. So here, when you want to rationalize this, we said square root of a times square root of a is equal to a. So by doing this, we've been able to transform from the square root to what a rational or whole. So it's the same idea. So you can say let's multiply both the denominator and the numerator by a. And I told you we've not changed the form, because in mathematics, when you multiply and divide by the same amount, you've done nothing to the expression. When you have 2 over 3 and you decide to multiply it by 100 over 100, 100 is 1. So still have not done anything. So when you say 2 over 3 times 100 over 100, maybe the final answer was 2 over 3. So when you add this one to it, you've not changed anything. The answer still remains 2 over 3. But someone can choose to expand 2 times 100 to get 200, and then 3 times 100 to get 300. Yet when you simplify, aren't you getting that same number? So it's the same thing. So let's take the first one. He said we should rationalize it. And the conjugate is easy to find. You can find the conjugate easy. For example, when I have root of a minus root of b, the conjugate is just root of a plus root of b. The only thing which changes is the sign. So when you have this expression and you have been asked to find the conjugate, is this one. Likewise, when you have this expression, find the conjugate, is this one. We just change the sign in between. Okay, so let's rationalize. And we said rationalization means we don't want to see that the denominator is what is a set. We want to see that every term of the denominator or every number of the denominator is whole. So the first one, 1 over 4 minus root of 5. We said for us to change a set of this nature, we have to multiply it by its conjugate. And what is the conjugate of this? Is 4 plus root of 5. Multiply divide by. So do you've not changed the question. The question remains this, because you've multiplied. You can say this can cancel this, yes. But for us to transform, we will not do that. We will expand. So we get 1 times multiplication of fraction a over b times c over d. What happens is that numerator will multiply numerator, and then denominator will multiply denominator. So here we have a times c over b times d. So the same thing here. We have 1 times 4 plus root of 5, and then 4 root 5, sorry, 4 minus root of 5 multiplying 4 plus root of 5. Now, this was the thing I wanted us to learn, and then I was proving certain things that we shouldn't brainstorm. Yeah, multiplying a set and its conjugate. You see, when I have this expression, a plus root of 5, and I multiply it by its conjugate, a minus root of 5. Oh, a plus minus root of b. What am I getting? Let's expand. When you do the expansion, this will multiply this. We have a squared. This will multiply this minus a root b. This will multiply this plus a root b. And then this will multiply this. We have minus b. Minus ab, a root b plus a root b will go. It will give us 0. So we have a squared minus b. So you can chew this or you can brainstorm this. So anytime you have a question like this nature, you can say, oh, the answer is just a squared minus b. So you identify your a. What is my a? My a is 4. What is my b? My b is 5. So can you use that better still? If you still can't keep so many, don't worry yourself. Don't worry myself. Let's go by the normal method. Here, we are continuing. 1 times 4 plus root of 5 is giving us the same thing. Because 1 times any number is that same number. All over. Now we have 4 minus root of 5 all over 4 plus root of 5. If you brainstorm this. So if you have time, with the conjugate, you don't have time, and I don't want to spend so much time. You can take a plus root of so whether a plus root of b or a minus root of b, you are going to get the same thing because this time this is the same as this time this. Multiplication is commutative, right? So that's how we do it. So always of this form, and then you can take this format too. When you have a plus root of b also, and then you multiply it by a plus root of b. I think when you do the expansion, you are going to get a plus b. So you don't necessarily okay, you solve this one. I will take my time to teach you. So let's see. 4 minus root of 5 multiplying 4 plus root of 5. What is the rule? The rule is what? A squared minus b. Our a is 4, our b is 5. So the denominator is going to give you a squared, which is 4. 4 squared is what? 16 minus, what's the term inside the square root? 5. What are we getting? 4 plus root of 5 all over 16 minus 5 is what? Is 11. Yes. But you can still decide to do the expansion. When you do that, when you get time, do that. You are going to get the same thing. Here, we've already expanded, and then we've memorized the final expression. It's a trick. If you want to be fast, you have to. Let's take one example here. Assuming I want us to do the possible cases. Root of a plus root of b. And now I've been asked to multiply it by its conjugate, which is root of a minus root of b. What am I getting? I will take this one, multiply by this, I get a. I will take that same number, multiply by this, I will get minus root a b. And I will take this one, multiply by this, I will get positive root ab. And I will take this one, multiply by this, I will get minus, oh, sorry, so yeah, it's a minus b. Yeah, I'll get minus b, because square root times square root is irrational, right? So here, this cancel this, we have a minus b. So always when I have any set at all in a form root of a, either plus or minus root of b, and I multiply it by its conjugate, I don't have to do the expansion. For example, you have 4 plus root of 5, and you've been asked multiply this by its conjugate. Let me say root of 4 plus root of 4. Though root of 4 is not a set, but let's go. So here, root of 4 minus root of 5, right? I know that the answer is a minus b. What is my a? A is 4. So the answer is 4 minus 5, which is the same as 1. So it's a trick that you can use. And if one of the term is not in the square root, like we have 2 plus root of, let's say, 7, and then you have been asked to multiply by its conjugate. Here is the rule: a squared minus b. What is a? A is 2. 2 squared is what? 4. Minus b is 7, giving you negative 3. When you have time, work out the possible cases and you get tricks. The key thing is for you to be fast. Yeah, I think these are sample WASI questions. Let's see. The question is saying express 2 root 5 plus 5 root 2. So with the remaining questions, and let me see your answer in the comment section. Express 2 root 5 plus 5 root 2 all over 2 root 5 plus 5 in the form. Look at the form. Q plus R root x. You see that in this particular form, we don't have a denominator, which is a set, right? So that should come into your mind is that, oh, let me rationalize it. Yes, because the final expression doesn't have any term, which is a set. So we rationalize the expression first. So we rationalize and then we simplify. 2 root 5 minus 5 root 2. Right. This is the question. So let's rationalize. We have 2 root 5 plus 5. Yes, root of 2. Yes, 5. All over 2 root 5 minus 5 root 2. So we multiply by its conjugate, right? The conjugate, not the conjugate of this, but the conjugate of the denominator. What is the conjugate of the denominator? Here is minus, so it will be plus 2 root 5 plus 5 root 2. Same thing. 2 root 5 plus 5 root 2. Someone is asking, why didn't you multiply the denominator 2 by the conjugate? No, I said whatever you multiply at the top should be the same to multiply below, right? So if you multiply the numerator by 10, you shouldn't multiply the denominator by negative 10. If you do so, you've changed the expression. I don't want to change it, right? So these are things I ask you to play around. So you can just have a root b plus c root d and then multiply by its conjugate. I think we did it in one of the examples where I said you shouldn't memorize that one. I think it's like, don't worry. But I've already told you to play around. So let's expand. Let's expand. You see, you can treat this as A, and then you treat the whole of this as B, right? And then, so it's more like, so we have A minus B multiply plus B. Is it not difference of two squares? And with difference of two squares, what are you going to get? You're going to get A squared minus B squared, right? If you remember, how did we get that? You take the first expression, multiply by the whole of this, minus, you take the b, multiply by the whole of ab. When you simplify, you're going to get this. So it's the same thing that we are using. Don't be confused. So it's the same thing. When you multiply a set by its conjugate, what you are getting, or your final answer that you are going to get, is difference of two squares. That's the key thing. So here, so you don't necessarily even have to chill for each case. The case is always one. So here, we have this one. So you can treat this to be your A. You treat this your B. This is your B. So it's more like you have 2 root 5 plus 5 root 2 multiplying this one. 2 root 5 plus 5 root 2 all over A minus B multiplying A plus B, right? So let's simplify it. Here, you know that your A is 2 root 5 and your B is minus 5 root 2. Okay, so here, let's multiply. So here, you can even, okay, let's multiply this one. I think we get 2 root 5 multiplying 2 root 5 plus 5 root 2 and then plus 5 root 2 multiplying 2 root 5 plus 5 root 2, right? All over A squared minus squared. Now let's substitute the values. So let's expand here to 2 root 5 times 2 root 5. Multiply the outside, multiply the inside. 2 times 2 is 4. Root of 5 times root of 5 is 5. Root of A times root of A is A. So root of 5 multiplying itself is that same number without the roots. Okay. Then we use this to multiply this. 2 times 5 is 10. Root of 5 multiplied by root of 2 is 5 times 2, 10. Okay. Plus, we use this, multiply this. 5, 2, 10. 2, 5, 10. Okay. Same thing. Outside, inside. 5 times 5 is 25. Square root of 2, square root of 2 is 2. I already told you, square root of a number times square root of that same number is that same number. What is our A? Our A was 2 root 5. So we have 2 root 5 squared minus, what is our B? Our B is 5 root 2. We have 5 root 2 squared, right? So we are simplifying. 4 times 5 is what? 20. 10 root 10. Okay, let me write it again. 10 root 10 plus 10 root 10 plus 25 times 2 is 50. All over. What is this one squared? It's the same thing as this number multiplying itself. 2 root 5 squared is the same as 2 root 5 times 2 root 5. What did I say? Outside, inside, inside. So let's use that. Outside, outside. So 2 squared is 4. Square root of 5 times square root of 5 is what? Outside square. 5 times 5 is 25. Square root of 2 times square root of 2 is 2. So let's see. Let's do like terms here. 20 plus 50. 20 plus 50. And then 10 root 10 plus another 10 root 10. All over. 4 times 5 is 20. Minus 25 times 2 is what? Is 50. What do we have? 20 plus 10 is 70. 20 plus 50 is 70. Plus 10 root 10 plus 10 root 10. You can take one of the root 10. And then you add outside. 10 plus 10 is 20. All over. 20 minus 50 is what? Negative 30. So I'm coming here. I'm continuing from this side. I have 70 plus 20 root of 10 all over minus 30, right? But the question says we should express our answer in this form, right? What we can do is simple. You can, here, you know that A plus B all over C is equal to A over C plus B over C. So here is the same as minus 70 over 30 plus, remember it's the same as 70 over negative 30, but 70 over negative 30, you can bring the negative upwards to give you negative 70 over 30. Same thing. Plus, I mean, yeah, plus, minus, minus, plus and minus is equal. So, minus 20 over 30 root 10, right? So now, what is Q? Q is given by minus 70 over 30, right? What is our R? R is given by minus 20 over 30. I think we can simplify 2 over 3 minus 7 over 3, right? What is our S? Our S is 10. Yes. Okay. So that was a very nice question. Yeah, so try your hands on the rest. Let's do this one, the third example. It's very, very crucial. Let me clean certain areas. Hold on. But I really hope you are enjoying. If you don't understand anything, comment section is there for you. Let's solve the third one. The third one is saying 3 root 7 multiplying 7, sorry, 3 root 7 multiplying 7 minus 2 root 7. Let's expand this one. This one times this is going to give us 21 root 7 minus, then multiplication outside, outside, inside, inside. 3 times negative 2 is negative 6. Root of 7 times root of 7 is going to give us 7, right? What are we getting? We are getting 21 root 7 minus 6, 7, 42. Okay, but now we've been given the value of 7, which is 2.646, right? So where we see root of 7, let's replace it by its value. We have 21 multiplying 2.646 minus 42. And when I punch it on my calculator, 21 point, oh sorry, 21 times 2.646. This expression is 55.566 minus 42, right? And when you simplify further, I think you are getting 13.566. So for you to know that you are correct, just punch the whole thing on your calculator and see. If you punch it on a calculator and then you get an answer which is closer, because this one they use an approximated value. I think the calculator gave me 10.374 and you had 13. Let's troubleshoot. This is 3 root 7 multiplying 7. So you get 21 root 7. And then this 3 root 7 is multiplying this. Negative 6 times 7, 42. Okay. I don't know why we had it wrong, but, or maybe it's because of the approximated value. Maybe because of the approximated value. Yeah, I don't know. I see any mistake, you address it. Okay, so that's one thing. So with this one, with this type, just expand it. If it needs reduction, reduce it with basic form, and then or into a form where you are going to get root of 7. Sometimes not necessarily the basic form. Check the value that they've given you, and try to work around that. Okay, I think quality of the last. Yes, finding a positive square root. I know this one, a lot of people didn't quite get it. Okay, sorry. The question, let's find the positive square root of alpha plus 2 root 2, right? So basically, we've been asked to do this. Find the square root of 3 plus 2 root 2. And we said we always see this expression is always in the form root of A plus root of B, because here is plus, here is plus. If here had been minus, we would have written minus. Yes, and I explained the reason why it is the final answer is in this form. Yeah, I gave you the reason, right, in the previous video. I don't want to waste my time. It's quite simple and logical. Yes, in that when you find the square of this, you are going to get an expression in the form rational plus z. And then when you find the square of this, you're also going to get an expression in the form. You're going to get 3 plus 2 root 2, right? So this is a rational, this is a set. So if you assume it is in this form, and then when you square this one, you are getting the square. So basically, left hand side is equal to right hand side, right? So we see, we make that, and then we use it. 3 plus 2 root 2 is equal to square root of A plus square root of B. So our task is to find A and B, right? So basically we said, first of all, we have to square. The idea is to get rid of the square root. So you square both sides. When you square both sides, I think we have 3 plus 2 root 2. When you square, is the same as square root of A plus square root of B, all squared, right? And when you square this, we are going to get, this is square root. So A number squared, square root of a square of a number is the same as that same number. By now you understand. Then plus 2 root 2 is equal to, let's expand this one. I've already told you to work around this. This one, you can write the answer easily. You see, when you have a plus b all squared, the expansion is always going to give you a squared plus 2ab plus b squared. So you can substitute. What is a? This is a. What is our a is root of a. And then what is b? Our b is root of b. So you can use that, or you can expand it like me. I always want to reason from first principle. So let's do so. Okay, so we have 3 plus 2 2. But then if you learn these things, it makes you faster. This one, when I look at this, I can predict the answer that we are going to get a plus 2 root ab plus b. But let's use the normal approach. So we are doing this right. So we take root of a, we multiply by root of a plus root of b plus root of b multiply by root of a plus root of b, right? So we say 3 plus 2 root 2 is equal to, this time this is what? A. This time this is ab. This time this is root of ab. This time this is b. So we get 3 plus 2 root 2 is equal to, hold on, a plus b plus this a plus this b. This one plus this one is addition of cells to root of ab, right? Yes. And we use the idea of equality of cells, that if two cells are equal, this one, this part must be equal to this part, and then this part must be equal to this part. So we say, hold on, we say this one, we say a plus b is equal to 3, and then we name it as an equation 1, and then 2 root 2 must be the same as 2 root ab. Can divide through by 2, we get root of 2 is equal to root of ab. This implies 2 is equal to ab, and call this equation 2. Yeah. So here someone will say, let's square both sides. When you do so, this will cancel, the square root will go leaving. So now we have a plus b is equal to 3, ab is equal to 2. So you can see this is equation 2, right? Let a, or let's make a the subject from equation 2. You get a is equal to b over 2. And then we put it in this equation. You get b over 2, which is a, plus b is equal to 3. I think we expand, multiply through by 2, we get b plus 2b is equal to 6. I think something is wrong. No, a is equal to 2 over b. So instead of b over 2 is, we should get a quadratic equation. That's why. So this is, sorry for the, we make a the divide through by b. This b cancel this b, we get a is equal to 2 over b, right? So putting it into equation 1, we have a plus b is equal to 3, right? Now we have an expression for a, which is 2 over b. So 2 over b plus b is equal to 3. So we multiply through by b, giving us 2 over b plus b squared is equal to 3b, right? And then finish. Yeah. No, the b is gone. We have b squared coming from this one. We transpose this one, or we move this one here, minus 3b, and then the 2 we maintain, plus 2. So you can solve this quadratic equation. I've already told you, look for factors of 2. which is 1 and 2. 1 times 2 is 2, right? So we have b square minus b minus 2b plus 2 is equal to 0, right? You factorize b out, you get b minus 1 minus 2b minus 1. Okay, so we have b minus 2, b minus 1 is equal to b is equal to 2 or 1. Therefore, you can say a is equal to 2 and then b is equal to 1. I've already told you, always choose the highest value for a. That's the condition. The condition is that the positive square root is always in the form root of a plus root of b, where a is greater than b. Okay, so I think the rest you can do it. See. So with this, go and solve this one. Find the positive square root of this. With this one, it's very, very simple. Just expand the terms and then let's do it. Let's do example 2. So let's expand. We take the 3, we multiply by the whole of this, right? Multiply by 2 minus a root 3 plus this 4 root 3. Multiply by 2 minus a root 3. And then we equate negative 8 plus 2 root 3. Here we get minus 3a root of 3 plus, here we get 4 times 2 is 8. 8 root of 3 minus 4 times a is 4a. And then root of 3 times root of 3 is 3. Is equal to negative 18 plus 2 root 3. Can we simplify further? So here, group like terms, we have this 6, okay, minus 3a root 3, and then here is also root 3, so we can factorize it. So we get plus root of 3. So we factor root of 3 out. Here is minus, right? So we get minus 3a plus 8 minus 4 times 3 is 12. 12a is equal to negative 18 plus 2 root of 3. Let me scroll down. Wow. So we get 6 plus 3a times root of 3 is minus 3a root of 3 plus 8 root of 3 minus of a equal to negative 18 plus 2 root 3, right? Uh, so this one 6 and then minus 12, they are the rational parts, right? So we bring them together. 6 minus 12a, and then we can factorize this. We get plus minus 3a root of 3, right, is equal to minus 18 plus 2 root 3. So here, when you get to this side, you can see let the whole of this equal to this, if I'm right. You get 6 minus 12a is equal to negative 18. So what is our a? So we get minus 12a is equal to negative 18 minus 6. Minus 12a is equal to minus 24. A is equal to positive 2. We divide through by negative this thing. Negative 2. You will get minus 24 over minus 12. So a is equal to 2. A is equal to 2. We use this side for the comparison. Let's use this side too and see if you are going to get. So here you are going to see 8 minus 3a is equal to 2. If a is actually 2, here 2, we have to get a to be 2. So with this, when we are finding, if you can use either this side or that side, but I'm saying for this particular question, because I'm teaching, I'm using both of them. But if you did everything right, we have to get a to be 2. Let's see. Minus 3a is equal to 2 minus 8. You send this one here. Okay, so we have minus 3a is equal to minus 6, right? And then a is equal to 2, yes. So this one, a is equal to 2. Okay. Radical equation. This question is incomplete. It's equal to 7. So solve it. Try your hands on this one. I will solve the second one because it's easy. With radical equation, the idea is to get rid of the square root, right? So here, for the first example, for you to get rid, you have to send this one here, so that when you square, this portion of the square root to go. After that, this become rational. And this side, which is the right hand side, will contain both rational and then set. Then you send those rational to the left hand side, so that the left hand side will be all rational, and then there will be a set at the right hand side. Then you square both sides to remove that set. We did it in a previous video. I think it's nothing new. Example of this one we didn't do. We just simply square both sides of the equation. When you do that, you are going to get s squared plus 7. When you square this one, the square root will go, and when you square 3, you get 9. So you get s squared minus 7. So you can send this one here. S equal to 2 minus 7 is what? 2. X is equal to square root of. That's all. So you use that same idea, you solve this one. This one you can send this x here, and then you square both sides of the equation. I don't think it's anything difficult. Okay, so that's all for said, and I'll make video. Don't worry, you cover it of the top that you have to. I'm using the SHS Ghanaian syllabus. So wherever you are, just stay tuned for the next episode. Please and please, if you feel that this video has really helped you, please subscribe to my channel, AD Mathematics. Share the video to your friends as well, so that they may also benefit. And please subscribe once again. See you in the next episode. Bye bye.